assumptions. Okay, so yesterday we have discussed about this Fourier's law of heat conduction, that is the rate of heat flow through a simple homogeneous solid is directly proportional to the area of section at right angles to the direction of heat flow. So Q is directly proportional to area and dt by dx. So this dt by dx is nothing but temperature gradient, means change in temperature with respect to distance. So Q is nothing but heat flow through a body per unit area. So unit is watt. Then area is nothing but surface area of heat flow, that is perpendicular to the direction of heat flow. Then dt is nothing but temperature difference of the faces of that particular block or particular component. And dx is nothing but thickness of that body in the direction of the flow. So q is equal to minus k into a into dt by dx, and k is nothing but thermal conductivity of that body. So the negative sign of k is to take care of the decreasing the temperature along with the direction of the increasing the thickness. So what are the assumptions? On that assumptions, this Fourier's law is depends. So write down the assumptions. The following are the assumptions. Write down assumptions. The following are the assumptions. Following are the assumptions on which Fourier's law is based. On which Fourier's law is based. On which Fourier's law is based. Fourier's law is based. So write down first, conduction of heat takes place. Conduction of heat. Conduction of heat takes place. Takes place under steady state conditions. Under steady state conditions. If there is a steady state condition, then and then only we have to use the Fourier's law of heat conduction. So for the deriving this Fourier's law of heat conduction, we have assumed this condition, that is steady state condition. Then second assumption, the heat flow is unidirectional. Write down second assumption, the heat flow is unidirectional. Means suppose we have to considering the one object. In that object there are so many directions are possible where the heat losses takes place. But for the deriving the Fourier's law, we have considering the only one direction, that is x direction. So this is the assumption for the deriving the Fourier's law, that is the heat flow is unidirectional. Then write down third assumption, the temperature gradient is constant. So that dt by dx should be constant, means what? The temperature profile is linear. So write down third assumption, the temperature gradient is constant. The temperature gradient is constant and the temperature profile is linear. And the temperature profile is linear. Okay, up to this point. Over. Anyone is remaining? Shall I proceed?
Yes,
Three
sir.
assumptions. Okay. So next assumptions, write down next assumption. Okay. Fourth assumption, write down. There is no internal heat generation. What is the meaning of this? Suppose we are considering the one component. In that component there is no internal heat generation. म्हणजे त्या component मधून heat generate झाली नाही पाहिजे. त्यावेळेस आपण काय करणार आहे? Fourier's law use करू शकणार आहे. So write down fourth assumption. There is no internal heat generation. There is no internal heat generation. Then next assumption, the bounding surfaces are isothermal. The bounding surfaces are isothermal. Means suppose we are considering the two components and that two components are attached to each other. So that bounding surfaces are isothermal. So whatever the temperature at the one end, that should be temperature for the adjacent surface. That is bounding surfaces are isothermal, means having same temperatures. So we are considering the same temperature at the bounding surfaces. Then next assumption, the material is homogeneous and isotropic. The material is homogeneous and isotropic. The material is homogeneous and isotropic. So what is the meaning of this? The value of thermal conductivity is constant in all direction. In bracket we have to write down K is constant in all direction. K is nothing but thermal conductivity. Okay, so these are the assumptions for the Fourier's law of heat conduction. Fourier's law of heat conduction. Okay, then write down next point, thermal conductivity of materials. Write down thermal conductivity of materials. Thermal conductivity of materials. Thermal conductivity of materials. So what is meant by thermal conductivity? We know that what is the definition of thermal conductivity? Ability of material to conduct heat. So in bracket we have to write down ability of material to conduct heat. Ability of material to conduct heat. So this is the simple definition for that thermal conductivity. Ability of material to conduct heat. Then write down below that Q is equal to, what is the Fourier's law of heat conduction? Q is equal to K into A into dt by dx. So we know that Q is nothing but rate of heat transfer, K is nothing but thermal conductivity, A is nothing but area which is normal to the direction of heat flow, dt is nothing but temperature difference, and dx is nothing but thickness of that particular object. Thickness of that particular object. So from this equation we have to write the equation for the K. So what is the equation for the K? So K is equal to Q by A into dx by dt. Write down K is equal to what? K is equal to Q by A into dx by dt. K is equal to Q by A into dx by dt. So now our aim is to understand the concept of the thermal conductivity. So when the thermal conductivity is equal to heat transfer, if the, suppose we have to consider the, if the, write down, if the area is equal to 1, means unit area is there, area is equal to 1, and dx by dt is equal to 1, means temperature gradient is equal to 1, area is equal to 1, and temperature gradient, that is dx by dt, is equal to 1, then K is equal to Q, means thermal conductivity is equal to amount of or rate of heat transfer. कधी असणार आहे? Thermal conductivity is equal to amount of heat transfer when there is a unit area and when there is a unit temperature gradient is there in unit time. At that time what we said that thermal conductivity is nothing but rate of heat transfer. Understood? What is meant by thermal conductivity? Thermal conductivity is nothing but the amount of energy. Q is nothing but the amount of energy conducted through a body of unit area and unit thickness in unit time. In unit time, when the difference in temperature between the phases causing heat flow is unit temperature difference. Means what? If unit area is there, then unit thickness is there, then temperature difference is also unit, and per unit time whatever the heat flow is takes place, that is nothing but thermal conductivity of that particular object or particular material. So write down, then K is equal to Q, K is equal to Q, and from this write down the definition of the thermal conductivity, that is the amount of energy conducted. The amount of energy means K is equal to Q. When this is possible? When area is unit, when temperature difference is unit, when thickness is unit, and when in per unit time we have calculated, then we get the thermal conductivity is equal to amount of energy conducted. So write down what is meant by thermal conductivity. The amount of energy conducted, the amount of energy conducted through a body, the amount of energy conducted through a body of unit area through a body of a unit area and unit thickness and unit thickness in unit time in unit time when the difference in temperature when the difference in temperature between the phases when the difference in temperature between the phases causing heat flow is unit temperature difference causing heat flow is unit temperature difference unit temperature difference full stop unit temperature difference full stop. Write down next para. From equation we can say that from equation we can say that material with high thermal conductivity from equation we can say that material with high thermal conductivity are good conductors. From equation we can say that material with high thermal conductivity are good conductors of heat. Good conductors of heat means thermal conductivity higher means that thermal conductivity high means good conductor of heat is there. Means maximum heat transfer will be takes place. And comma whereas material with low thermal conductivity low thermal conductivity are good thermal insulators insulators means if the material is having low thermal conductivity that material is nothing but good thermal insulator that material is insulator. So this is about the thermal conductivity. Write down next para. Thermal conductivity is property of material. Thermal conductivity is a property of material. Thermal conductivity is a property of material depends essentially upon the following factors. Depends essentially upon the following factors. So what are the different factors on which thermal conductivity is depends? So already in first lecture I have discussed this point, that is thermal conductivity depends upon the whatever the material structure, then whatever the moisture content in that particular material, then density of that particular material, and whatever the pressure and temperature of that particular material. So on these factors the thermal conductivity is depends. So write down what are the different factors. First one, material structure, material structure, material structure. Then second one, moisture content, moisture content, moisture content. Then third, density of material, density of material, density of material. And fourth one, pressure and temperature, pressure and temperature. So these are the factors on which thermal conductivity depend. Thermal conductivity depend. Okay, write down next point. Okay, so write down next point. In case of solids, already we have discussed that point. In case of solids, thermal conductivity of material is due to free electrons. So write down, in case of solids, thermal conductivity of material is due to free electrons. In solid, thermal conductivity because of what? Free electrons. Then second point, in case of liquids and gases, in case of liquids and gases, thermal conductivity is due to lattice vibrational waves or wave. In case of liquids and gases, conduction of heat is takes place due to the or thermal conductivity is due to lattice vibrational waves. In case of liquids and gases, thermal conductivity is due to lattice vibrational wave. Okay. Then pure metals will have highest thermal conductivity. So we discussed yesterday this point, that is pure metal consists of number of or maximum free electrons are there. So because of that, maximum heat transfer will be takes place. So due to that, pure metals will have highest thermal conductivity. Pure metals will have highest thermal conductivity. So we know that solid is having highest thermal conductivity as compared to the liquid and gases, and in solids pure metal consists of maximum number of free electrons. So as compared to the alloy, so pure metal is having higher thermal conductivity. So as compared to the alloy, in pure metal maximum number of free electrons are there. So because of that, pure metal is having high thermal conductivity as compared to the alloys. So write down the relation. Thermal conductivity of pure metal is greater than alloys, greater than liquid, greater than gases. So this is the relation for the thermal conductivity. So write down the pure metal. Asula, K of pure metal is greater than K of alloys is greater than K of liquid is greater than K of gases. Thermal conductivity of pure metal is greater than thermal conductivity of alloys, greater than thermal conductivity of liquids is greater than thermal conductivity of gases. Thermal conductivity of gases. Okay. So in first lecture, this point we have discussed, that is for the solid, if temperature increases, then what about the thermal conductivity? So for the solid, we know that if temperature is increases, then thermal conductivity will be reduces. So what is the reason behind this? As the temperature is increases, then molecular vibrations also increases, and this molecular vibration obstruct the flow of free electrons. Okay, flow of free electrons, and because of that thermal conductivity will be reduces. समजतंय बघा, सॉलिडचं जर टेम्परेचर वाढवलं तर थर्मल कंडक्टिव्हिटी कमी होते. तर त्याचं रिझन काय असणार आहे? तर टेम्परेचर वाढल्यानंतर व्हायब्रेशन्स इन्क्रीज होतात, आणि त्या व्हायब्रेशन मुळे काय होतंय, तर ते तुमच्या इलेक्ट्रॉनच्या फ्लोला ऑब्स्ट्रक्ट करतात, आणि जे काही कंडक्शन होत असते त्याच्यामधलं 70% वेटेज कशाला असते? फ्री इलेक्ट्रॉनला असते, आणि 30% वेटेज इज फॉर दी lattice vibration. So because of this obstruction of the flow of free electrons, the thermal conductivity will be reduces. So write down for solid T is increases, temperature is increases, then thermal conductivity, that is K is reduces. K is reduces. And next line we have to write down the reason. What is the reason? Because if temperature is increases, then thermal conductivity is reduces. Write down the reason. Here I have written the reason for solid. As the temperature increases, write down for solid, as the temperature increases, the molecular vibrations increases. As the temperature increases, the molecular vibrations increases. So molecular vibrations increases, so they obstruct the flow of free electrons. So they obstruct the flow of free electrons. So they obstruct the flow of free electrons, thus reducing thermal conductivity. Okay. So for the solid, if temperature is increases, then thermal conductivity will be reduces. And what is the reason? Temperature is increases, then molecular vibrations increases, and they obstruct the flow of free electrons, and because of that thermal conductivity will be reduces. Then next line, write down there are some exceptional cases are there. Means what is the standard statement? If temperature is increases, then thermal conductivity will be reduces. But some exceptions are there, that is aluminum and uranium. So for aluminum and uranium, this statement is not valid. So write down the exception aluminum, comma uranium. Exception, here I have written exception aluminum and uranium. Aluminum and uranium. Okay, so this is about the solids. This is about the solids. Write down for liquid. Next line, for liquid. For liquid, temperature is increases, T is increases. For liquid, T is increases means temperature is increases, then thermal conductivity will be reduces. If temperature is increases, then thermal conductivity will be reduces. Thermal conductivity will be reduces. And what is the reason behind this? That is, I have written this reason here. For liquid, decrease in density with increase in temperature, decrease in density with increase in temperature, and due to decrease in density, thermal conductivity reduces. So for the liquid, if temperature is increases, thermal conductivity will be reduces. What is the reason? If we are increasing the temperature, at the same time what will happen? Density will be reduces. And if density will be reduces, means number of molecules will be, the distance between molecules is increases, then automatically thermal conductivity will be reduces. So this is the reason for the, if temperature is increases, then thermal conductivity will be reduces. And for this liquid also there is one exceptional case, that is for water. For water, this statement is not suitable, that is temperature is increases, then thermal conductivity will be reduces. So write down exception is water. फॉर लिक्विड मध्ये काय असणार आहे, एक्सेप्शन काय असणार आहे, तर वॉटर साठी ही स्टेटमेंट सुटेबल नाही. ज्यावेळेला टेम्परेचर वाढणार आहे त्यावेळेला थर्मल कंडक्टिव्हिटी कमी होणार आहे. एक्सेप्शन इज वॉटर. सो राइट डाउन एक्सेप्शन इज वॉटर. सो आय हॅव रिटन हियर एक्सेप्शन इज वॉटर. ओके, देन राइट डाउन नेक्स्ट लाइन फॉर गैसेस. For gases, if temperature is increases, then thermal conductivity will be increases. So many times this type of questions will be asked for the MCQ type questions. म्हणजे जे काही MCQ type question असणार आहे त्याच्यामध्ये हे बऱ्याच वेळेला विचारलं जाते की if temperature is increases, then what about the thermal conductivity of gases, what about the thermal conductivity of liquid, then what about the thermal conductivity of the solid. So we have to remember these all points. We have to remember the reason. So from that reason we have easily understood what about the thermal conductivity. So write down for gases, if temperature is increases, then thermal conductivity also increases. And what is the reason? I have written the reason here. Molecular vibrations increases. Molecular vibrations increases means if temperature is increases, then molecular vibrations increases and causing more molecular collision. मॉलिक्युलर व्हायब्रेशन्स काय होणार आहेत तर इन्क्रीज होणार आहेत आणि त्याच्यामुळे काय होणार आहे, मोर मॉलिक्युलर कोलिजन होणार आहे. बिकॉज ऑफ दॅट कोलिजन कंडक्शन इज टेक्स प्लेस अँड ड्यू टू दॅट इफ टेम्परेचर इज इन्क्रीजेस, देन थर्मल कंडक्टिव्हिटी ऑल्सो इन्क्रीजेस फॉर दी गॅसेस. सो राइट डाउन द रीजन. मॉलिक्युलर व्हायब्रेशन्स इन्क्रीजेस कॉजिंग मोर मॉलिक्युलर कोलिजन. So this reason I have written here. Molecular vibrations increases causing more molecular collision. Okay, so this is about the effect of temperature on the thermal conductivity for the solid, liquid and gases. So we have remember this. T is increases, thermal conductivity decreases for solid and liquid, and for the gases if temperature is increases, then thermal conductivity increases. So all of you write down these values of the thermal conductivity of different materials. So write down first column, that is material, and second column we have to make as a thermal conductivity, and write down the different materials. First material is silver, second material is copper, silver, copper, aluminum, cast iron, steel, concrete, glass, water, then alloys, liquid, gases, and write down the values of the thermal conductivity of these different materials. So for the silver, what is the thermal conductivity? 410 watt per meter Kelvin. Then what is the thermal conductivity of copper? 385. Then what is the thermal conductivity of aluminium? 225. Then what is the thermal conductivity of cast iron? 55 to 65. Then what about the thermal conductivity of steel? That is 20 to 45. Then what about the thermal conductivity of concrete? That is 1.20. Then what about the thermal conductivity of glass? That is 0.75. 0.75. Okay. And what about the water? 0.55 to zero point 0.7. 55 to zero point 0.7. So these are the thermal conductivities of the different materials. So from these materials we have to understood silver is having highest thermal conductivity, that is 410, and water is having lower thermal conductivity, that is 0.55 to zero point 0.7. Then at the right hand side I have written the thermal conductivities for the alloys, liquids and gases. So write down that values also. For the alloys, K is 12 to 120 watt per meter degree Celsius. Then what about the liquids? What about the liquids? Thermal conductivity is 0.2 to zero point 0.5. So from this value, we also understood the thermal conductivity is more for the solids as compared to the liquids and gases. So for the liquid, what is the value? K is equal to 0.2 to zero point 0.5, and for the gases, K is equal to 0.006 to 0.05. 0.006 to 0.05. So these are the different values of the thermal conductivities for the solids. In that solids, we have considered the different material, that is silver, copper, aluminium, cast iron, steel, concrete, glass. Then liquids having less thermal conductivity as compared to the solids, and gases having less thermal conductivity as compared to the solids and the liquids. So here we have covered the Fourier's law of heat conduction. After that, we have covered the what is meant by thermal conductivity. Then we have derived the different relations between the what about the if temperature is increases, then what about the thermal conductivity. So here we have completed the Fourier's law of heat conduction and the thermal conductivity, the concept which is thermal conductivity for the different materials. So now we have to cover the next concept. So write down next concept. Write down. Okay. So write down next point, electrical analogy or thermal resistance. Write down electrical analogy, electrical analogy or or thermal resistance, thermal resistance, thermal resistance, electrical analogy or thermal resistance. So basically we know that heat is always in transient nature, means it is in a continuous motion or continuously is in the movement. So our next concept is electrical analogy, means our subject is what? Heat. We are studying about the heat, and now we have to comparing this heat with respect to electrical system, means in the electrical system which parameter is continuously in the movement, that is current. In the electrical system which parameter is continuously in the movement, that is nothing but current. And in our subject, that is heat transfer subject, heat is always in the transient, means it is in the continuous movement. So now we have to understood the concept of electrical analogy, means we have to considering the one electrical parameter and we have to considering the one heat transfer parameter, and we have to see the similarities of these two parameters. Okay, analogy means what? Similarity. Okay, so whatever the factors in factor, how it is similar to the heat transfer system. Okay, so we have to consider that electrical analogy means we have to comparing the two systems. We have to comparing the two systems. So what is meant by electrical analogy? When two physical systems are described by the similar equations and have similar boundary conditions, these are said to be analogous. म्हणजे ज्या काही दोन physical systems असणार आहेत, for that two physical systems the equations should be same and having boundary conditions are the same. At that time what we said that two physical systems are analogous to the each other. Understood? ज्या वेळेला दोन system असणार आहेत physical system and for the both system having same equations are there and having same boundary conditions are there, then we said that two physical systems are analogous to the each other, analogous to the each other. So write down the what is meant by electrical analogy. Write down when two physical systems when two physical systems are described by when two physical systems are described by similar equation similar equation similar equation similar equation and have similar boundary conditions and have similar boundary conditions these are said to be analogous. These are said to be analogous. These are said to be analogous. समजले का बघा? इलेक्ट्रिकल अनालॉजी म्हणजे आपल्याला काय करायचं आहे, जी काय आपली हीट ट्रान्सफर एक फिजिकल सिस्टीम आपण कन्सिडर करणार आहे, तशीच आपण एक इलेक्ट्रिकल सिस्टीम कन्सिडर करणार आहे आणि ह्या दोन्ही सिस्टीम एकमेकांना कशा अनालॉगस आहेत ते आपण काय करणार आहे, चेक करणार आहे. सो राइट डाउन फॉर द नेक्स्ट लाइन, द हीट ट्रान्सफर प्रोसेसेस मे बी कंपेयर्ड the heat transfer processes may be compared by the heat transfer processes may be compared by analogy with the flow of electricity in an electrical resistance. The heat transfer processes may be compared by analogy with the flow of electricity in an electrical resistance. Can anyone tell me what is the Ohm's law? What is the equation of the Ohm's law? Anyone? What is the equation of the Ohm's law? Rhythm. What is the equation of the Ohm's law?
Yes, sir. V is equal to IR.
Okay. So V is equal to IR. So what is mean by V? V is nothing but voltage and I is nothing but current flowing through that particular wire and R is nothing but resistance. Suppose I have written this equation as a I is equal to V by R. Means what? In the electrical system current is flowing. In the electrical system current is flowing because of the potential difference or voltage difference. If there is a voltage difference, at that time current is flowing. Means in the electrical system current is flowing because of the potential difference is there. Means dV is there, voltage difference is there. Okay, so current is flowing because of the potential difference, and which factor is opposing this current? That factor is nothing but resistance. So what is the equation? I is equal to dV by R. So I is flowing, current is flowing because of this potential difference, because of this dV. Means potential difference is increases, then automatically current will also increases. But what about the resistance? Resistance opposes the current. Means if current is increases, at the same time what will happen? Resistance will be reduces. But if resistance is increases, then at that time what will happen? Current will be reduces. So this is the one system, that is one physical system we have considered, that is electrical system. Now our aim is to compare this electrical system with the heat transfer system. So we know that This is the electrical system equation, that is I is equal to dV by R. I is equal to dV by R means current is flowing because of the potential difference, and the resistance for the current is nothing but R. Okay, so I is equal to dV by R. This is the one equation for the electrical system. Now we have to write the equation for the heat transfer system. So we know that one heat transfer system equation for the conduction, that equation is nothing but Fourier's law of the heat conduction. So anyone tell me what is the equation for the Fourier's law of heat conduction? Q is equal to what? Anyone? Already we have written that equation. So what is that equation? Q is equal to what? Reply me fast. Unmute yourself and tell me. Q is equal to what? Anyone? सगळे झोपले का काय? Hello? What is the Fourier's law of heat conduction? What is that equation? Q is equal to what?
Ka dt by dx.
Q is equal to Ka dt by dx.
dx.
So, okay. So, Q is nothing but rate of heat transfer. So, Q is flowing. Heat transfer is takes place because of what? Heat transfer is takes place because of the temperature difference. म्हणजे ज्या वेळेला टेम्परेचर डिफरन्स असणार आहे त्यावेळेस आपली हीट काय होणार आहे? फ्लो होणार आहे. आपण इलेक्ट्रिकल सिस्टीम मध्ये काय म्हणतोय? आपला करंट कधी फ्लो होणार आहे? करंट इज फ्लोइंग व्हेन देयर इज ए पोटेन्शियल डिफरन्स. So my question is that now we have to write down the equation of the heat transfer in the form of electrical system equation. Means what? If current is flowing, which because of what current is flowing? Because of the potential difference. So at the numerator dV is there, and at the denominator which factor which is opposes the current, that is R is there. So in that way we have to write down the equation for the heat transfer system. So Q is equal to, what is our equation? Q is equal to K into A into dt by dx. So current is flowing because of what? Current is flowing because of the temperature difference. So only we have to take temperature difference at the numerator, and remaining part we have to take at the denominator. So what is the factor which is coming at the denominator? Anyone tell me? Only temperature difference. Because of the temperature difference current is flowing. So Q is equal to dt is only at the numerator, and remaining part we have to take at the denominator. So anyone tell me what factor at the denominator of this equation? कुठला फॅक्टर डिनॉमिनेटरला असणार आहे सांगा. आपल्याला काय करायचं आहे? हीट ट्रान्सफर कशामुळे फ्लो होते? तर टेम्परेचर डिफरन्समुळे फ्लो होते. तर तो टेम्परेचर डिफरन्स आपण न्यूमरेटरला घेणार आहे, अँड रिमेनिंग part of that equation we have to take at the denominator. So what is the remaining part which is at the denominator? Can anyone tell me? Tell me what is the remaining part which is at the denominator? Rhythm?
Area, sir.
Only area is there. Our equation is Q is equal to K into A into dt by dx. Okay. So at the numerator we have to take only dt. Remaining we have to take at the denominator. So what is the equation at the denominator? न्यूमरेटरला फक्त टेम्परेचर डिफरन्स ठेवायचा, म्हणजे आपण dt आहे असं न्यूमरेटरला ठेवणार आहे, आणि बाकीचे जे सगळं जे इक्वेशन आहे आपलं ते डिनॉमिनेटरला घेणार आहे. म्हणजे तुमचा के असेल, ए असेल, तर तो डिनॉमिनेटरला घेतल्यानंतर इक्वेशन काय होईल डिनॉमिनेटरला? ओके, आरती के इंटू क्यू इंटू डीएक्स. रॉंग आहे. के इंटू ए जर न्यूमरेटरला असेल तर डिनॉमिनेटरला गेल्यानंतर काय होणार आहे? ते डिनॉमिनेटरच्या डिनॉमिनेटरला जाणार आहे. ओके, सो व्हॉट इज द इक्वेशन ॲट द डिनॉमिनेटर? दॅट इज dx बाय के. के इंटू ए हा जर न्यूमरेटरला असेल तर आपल्याला जो खाली घ्यायचा असेल तर तो कुठे घेणार आहे तुम्ही? डिनॉमिनेटरच्या डिनॉमिनेटरला जाणार आहे. सो dx डिवायडेड बाय के, दिस फॅक्टर इज ॲट द डिनॉमिनेटर. सो नाउ वी हॅव टू इक्वेशन्स. For the electrical system, I is equal to dV by R, and for the heat transfer equation, Q is equal to dt divided by dx by K. Now compare these two physical systems. One is electrical system and one is heat transfer system. Now we have to comparing these two systems. So current is similar to what? Current is also flowing, heat is also flowing. So current is analogous to what? Current is analogous to rate of heat transfer. Similarly, current is flowing because of the potential difference, and heat transfer is takes place because of the temperature difference. So potential difference is analogous to what? Potential difference is analogous to temperature difference. And resistance, which is analogous to what? Resistance is analogous to dx by k. हा रेजिस्टन्स म्हणजे काय असणार आहे? जो करंटला अपोज करतोय. मीन्स व्हॉट? इन द हीट ट्रान्सफर सिस्टीम विच फॅक्टर अपोजेस द हीट? That factor is nothing but dx by k, and that dx by k is nothing but thermal resistance. Means that factor opposes the heat transfer. So what is our heading? That is electrical analogy or thermal resistance. So from this we get the equation of the thermal resistance for the heat, that is thermal resistance is equal to dx by k. तर हे कशावरून आपण काढलेलं आहे? तर ह्या दोन फिजिकल सिस्टीम आपण काय केलेल्या आहेत? कंपेअर केलेले आहे. त्याच्यामधनं आपण एनालॉजी काढलेली आहे. फ्रॉम दॅट एनालॉजी वी गेट दी थर्मल रेजिस्टन्स इज इक्वल टू dx बाय k. थर्मल रेजिस्टन्स इज इक्वल टू dx बाय k. तर इथं दिलेलं आहे बघा सगळं. Okay, so as per Ohm's law, we know that Ohm's law, current is equal to potential difference divided by electrical resistance. Means I is equal to dV by R. Means current is flowing. This current is flowing because of this potential difference, and this electrical resistance is opposes the current. This electrical resistance is opposes the current. Okay, so this is the equation for the one physical system, that is electrical system. And we know that for the heat transfer system there is a one equation for the conduction, that is Fourier's law. So what is the equation of Fourier's law? Q is equal to k into A into dt by dx. Okay, so similarly in the form of current we have to write the equation. Means current is flowing because of the potential difference, so we have to write down the heat is flowing. This heat is flowing because of the temperature difference, so we have to take only temperature difference at the numerator. So this k into A is at the numerator, so we have to take at the denominator. Means where it is going? At the denominator of denominator, so it is at the dx by k. So what is the our equation? Heat flow rate Q is equal to temperature difference divided by dx by k. हा k न्यूमरेटरला म्हटल्यानंतर तो कुठे जाणार आहे? डिनॉमिनेटरला घ्यावा लागणार आपल्याला. सो Q is flowing because of the temperature difference. Q is flowing because of the temperature difference. Similarly, current is flowing because of the potential difference. इथं आपण काय म्हणतोय? करंट कशामुळे फ्लो होते? बिकॉज ऑफ द पोटेन्शियल डिफरन्स. आणि करंटला कोण अपोज करतोय? तर जो काय फॅक्टर तुमच्या डिनॉमिनेटरला आहे, म्हणजे हा जो काही रेजिस्टन्स आहे, दॅट फॅक्टर अपोजेस द करंट. सो सिमिलरली इन द हीट फ्लो, विच फॅक्टर अपोजेस द heat transfer? That factor is nothing but dx by k. So that dx by k is nothing but resistance for the heat. And what is the name of this? That is thermal resistance. So by comparing, this is one physical system, that is electrical system, that is equation number 1, and this is the heat transfer system, that is equation number 2. So from these two systems, current is analogous to what? Heat. Then potential difference is analogous to what? Temperature difference. And R is nothing but resistance is analogous to what? Dx by k. And this quantity, that is dx by, is called as thermal conduction resistance. So therefore R thermal conduction is equal to dx by k. So this is the concept of the thermal resistance. तर हा पॉइंट जो असणार आहे तो आपल्याला ज्यावेळेला आपण प्रॉब्लेम सोडवणार आहे तर प्रत्येक ठिकाणी हा थर्मल रेजिस्टन्स येणार आहे. So we have to understood that thermal resistance is nothing but that factor which opposes the heat transfer. आणि तो फॅक्टर कुठला आहे? डिनॉमिनेटरचा फॅक्टर आहे. आणि डिनॉमिनेटरला काय आहे? तर dx by k आहे. तर हा dx by k फॅक्टर काय करणार आहे? तुमच्या हीट फ्लोला अपोज करणार आहे, रेजिस्ट करणार आहे. So because of that the name is given as thermal resistance for the conduction is equal to dx by k. So we get the equation of the thermal resistance. So all of you write down from this. Okay, as per Ohm's law, write down, as per Ohm's law, as per Ohm's law, current is equal to, in bracket, current I is equal to potential difference in bracket dV, potential difference in bracket dV divided by electrical resistance in bracket R, electrical resistance in bracket R. This is the equation number 1. इक्वेशन नंबर 1 म्हणजे हे जे इक्वेशन आहे ते कुठल्या सिस्टीमचं आहे, इलेक्ट्रिकल सिस्टीमचं आहे, आणि दोन फिजिकल सिस्टीम आपण काय करणार आहे, कम्पेअर करणार आहे, त्याच्यामधनं अॅनॉलॉजी आपण फाइंड आउट करणार आहे. ओके, सो ऍज पर फोरियर्स लॉ, write down next line. As per Fourier's law, Q is equal to, what is the equation of Fourier's law? Q is equal to K into A into dt by dx. Q is equal to K into A into dt by dx. Q is equal to K into A into dt by dx. Okay, write down at the next line. By analogy, the heat flow equation written as, by analogy, analogy means similarity of the electrical equation. In that form we have to write down the equation. So by analogy, the heat flow equation written as, heat flow rate Q is equal to, temperature difference in bracket dt, temperature difference dt means हा जो हीट ट्रान्सफर, हीट फ्लो होणार आहे ती कशामुळे होणार आहे, टेम्परेचर डिफरन्स मुळे होणार आहे, आणि बाकीच्या सगळ्यामुळे काय होणार आहे, अपोज होणार आहे. म्हणजे हा के जो वरती होता तो आपल्याला खाली गेला पाहिजे. सो बिकॉज ऑफ दॅट ऍट द डिनॉमिनेटर dx divided by k. So this is the equation number 2. Equation number 2 means this is the equation number 1 which is related to the electrical system, and this is the equation number 2 which is the related to the heat transfer system. So comparing the equation 1 and 2, write down next line. Comparing equation 1 and 2, comparing equation 1 and 2, I is analogous to Q. I means what? Current is analogous to Q means rate of heat transfer. I is analogous to Q. Then dV is analogous to dt. dV is analogous to dt means current is flowing because of this potential difference, and heat is flowing because of the temperature difference, and R is opposes the current, and this dx by k opposes the heat. Okay, so R is analogous to dx by k. R is analogous to dx by k, dx divided by k. R is analogous to dx by k. Okay, so write down next line. The quantity dx by k is called thermal conduction resistance. The quantity dx by k is called thermal conduction resistance. म्हणजे जी काही हीट ट्रान्सफर कंडक्ट होणार होती, हीट जी काही कंडक्ट होणार होती त्या हीटला कोण अपोज करणार आहे, हा फॅक्टर अपोज करणार आहे. बिकॉज ऑफ दॅट द नेम इज गिवन ॲज थर्मल कंडक्शन रेजिस्टन्स. सो द क्वांटिटी dx by k is called thermal conduction resistance. Thermal conduction resistance. So that is, write down in bracket, that is next line, R thermal conduction is equal to, R thermal conduction, what is the notation for thermal conduction resistance? That is RTH, R into suffix th, bracket complete, conduction is equal to dx by k. dx by k. So this is nothing but thermal conduction resistance. So by using this equation we have to find out the thermal conduction resistance, and the reciprocal of the thermal resistance is called thermal conductance. Next line, write down the reciprocal of the thermal resistance is called thermal conductance. The reciprocal of the thermal resistance is called thermal conductance. Okay, so this is about the, today we discussed about the remaining part of the Fourier's law, that is assumptions. Then we have discussed about the what is meant by thermal conductivity, then what is the effect of temperature on the thermal conductivity for the solid, liquid and gases, then what are the values of the thermal conductivity for the different material, and next point we have covered the electrical analogy or thermal resistance. Okay, electrical analogy or thermal resistance. In next lecture we have to solve the problems related to the Fourier's law. Okay, so we have to stop here. Okay, so all of you put your roll number in the chat box. Only once you have to put your roll number.